Hi, today we begin a new unit on radicals. Our learning target today for the first lesson is I can simplify a radical expression. So let's start by answering that question. What is a radical expression? Well, it is what it sounds like. It's an expression that contains a radical or radical sign. Now, you may recognize this radical symbol as a square root symbol, and you would be right that a square root is one type of a radical. However, there's more than just square roots. There's actually cube roots, which would look like a square root symbol with a little 3 in the corner, or fourth roots, which looks like a square root symbol with a 4 in the corner, and basically any root that you could think of where you have a little number in that corner up front. Okay, that's called an index. All right, if there's no number there, it's that invisible 2 or imaginary 2, which represents a square root. Okay, so we have the radical symbol, and then what we have inside the radical is known as the radicand. Okay, so in this case, 45 is the radicand, the thing that we're trying to take the square root of. So today we're going to focus on simplifying these radicals. What that means for today is that the radicand, or the thing that's inside the square root, has no perfect square factors other than 1. Okay, so what are perfect square factors? So a perfect square would be the result of squaring a number, like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. So instead of thinking of it as, a number times itself, we can also say it's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and that would continue, right? That doesn't end. You just take a number times itself. So there's the first 9 perfect squares, and then actually 100 would be the 10th perfect square. And what we would try to do is see, is there a number, a perfect square from this list that I can actually divide out of 250? And you might recognize that 25 would actually divide out of 250 because it would be 25 times 10. Well, that actually allows us to break this radical into 2 radicals. And we'll talk about the property that allows us to do this in just a moment, but since 250 is 25 times 10, I can rewrite this expression as the square root of 25 times the square root of 10. And the whole reason why that's helpful and why we do that is because the square root of 25 is exactly 5. Because 5 times 5 is 25. So it ends up simplifying to become 5 times the square root of 10. The square root of 10 can't be simplified because it certainly can't be divided by these bigger numbers. We also can't divide it by 9 or 4. And yes, you can divide it by 1, but notice my rule up here says no perfect square factors other than 1, because dividing by something by 1 isn't going to change it. So what I have here is a perfect square multiplication table. Across the top of our list, we see our perfect squares. 1, 4, 9, 16, 25, 36, 49, and so on, all the way out to 15 times 15, which is 225. So this, as you move down the table, that's when you multiply the perfect squares by 1, 2, 3, 4, 5, 6, 7, and so on. For example, if I wanted to see if 243 could be simplified, or I should say the square root of 243, it can because it's the result of 81 times 3. 81 is a perfect square, 3 is not, which is okay. But 81 being a perfect square, that's the one that we can simplify. The square root of 81 is 9. It becomes 9 times the square root of 3. So that's pretty much what we're going to do today is we're going to look at simplifying radicals, and this perfect square multiplication table is here as a resource to help you with that. All right, so here's that product property of radicals that actually allows us to do what we're doing today. And the property just says that if you want to multiply 2 square roots together, you can do that. You just multiply the radicands. So the square root of a times the square root of b is the same as the square root of a times b. As an example, the square root of 3 times the square root of 5 is the same thing as the square root of 15, since 3 times 5 is 15. So let's go ahead and practice by looking at a couple of examples. Simplify each radical expression. Our first example says the square root of 81. Now you might remember that 81 is actually one of our perfect squares. It's the result of 9 times 9. So the square root of 81 is exactly 9. Now, there isn't a symbol in front, like a plus or minus symbol in front, so we know that we only want the positive answer. If, however, you came across something like this, we would want the answer to be negative 9. All right, so just a heads up for square roots, you're just going to give the principal square root or positive square root answer. For the square root of 40, let's see if we try to see if it's an easy answer. Can you think of a number times itself that equals 40? And it doesn't quite work. We can get close. 6 times 6 is 36, but that's too small. 7 times 7 is 49, but that's too big. So the square root of 40 is actually between 6 and 7. So it'll be 6 point something. Some number that goes on forever and never repeats. It's that irrational number. But we want to find the exact value as an equivalent radical expression for the square root of 40. So for that, we're going to use our table. Okay, and we're going to look for 40 in our multiplication table. Now the numbers on the right are quite large. You're not going to find 40 over here. But let's see, is 40 a multiple of 1? Well, that's not going to help us. It is, but it's not going to help us. Is it a multiple of 4? Yeah, here it is. It's the result of 4 times 10. So let's go back and show our work. So if the square root of 40 is the same thing as the square root of 4 times 10, all right, there's our two factors that our product property allows us to split into individual square roots, square root of 4 times the square root of 10. And the whole reason we do that is because the square root of 4 can be simplified. Remember that the square root of 4 is 2, because 2 times 2 is 4. So this is going to be 2, and then we just bring down the square root of 10. Now I don't need the multiplication dot in there. Anytime you have a number directly in front of a radical symbol, or if a letter, a variable is in front, it's implied that it's being multiplied together. Okay, so just like we normally see, if there's not a different operation symbol there, it is implied multiplication. So I do want to just go through this and show you that the square root of 40 is that number between 6 and 7. That's like 6.324555532, and it keeps going. It just only gives us 10 digits. And that's going to be the exact same as if I do 2 times the square root of 10. It's an equivalent value. So 2, and I should probably explain, the square root symbol on your TI-84 calculator is the same as the x squared button. Yours might actually be on the button itself, but because it's in blue, I have to press the blue button that says second first, and then I can press this button to get that function of it. Okay, so to get the blue symbol, I hit the blue button first and then that button, and then I'll see the square root, and I want to do square root 10. Remember, 2 square root 10 is supposed to be the exact same thing as the square root of 40. It's just simplified, so it should be the exact same value, which it is. Notice it is. Every digit is exactly the same. So the square root of 40 is the same as 2 times the square root of 10. Let's look at a few more. This time we have the square root of 180. Okay, so we have to try to think about, is 180 a perfect square? So let's check square root 180, and it is not a perfect square because we get these decimals here. So we want to see if there's a way to simplify the square root of 180. So try to think about what perfect squares might you be able to divide out of 180. Let's see, 180. It's not in this list or this list. Usually it's a good idea to start with the larger perfect squares, because if it can be divided by multiple perfect squares, we want to divide it by the biggest one. So I'm looking for 180, and I only have to go down as far as, once I start getting into the 200s, I know it's not going to be below that, the way a multiplication table works. So let's see, 100, here we go. 180 is 36 times 5. 36 times 5. So we are going to start by writing it as the factors, 36 times 5 instead of the square root of 180. Now I'm going to apply my product property, and I'm going to go ahead and split it into two individual square roots. It's still the same overall value. Square root of 180 is the same as the square root of 36 times the square root of 5. And now it's time to simplify. What is the square root of 36? In other words, what number times itself would give me 36? Well, I know that 6 times 6 is 36. So it's 6, and then we bring down the square root of 5. The one that you can't simplify stays in the radicand. So let's just double check on that calculator and make sure that that does in fact have an equivalent value. So the square root of 180 we already checked. Now let's see if 6 times the square root of 5 is the same thing. So 6, hit the square root button, 5, enter. It is the exact same value, 13.41640,786. And again, that number continues. That's not actually the exact value. It's just the calculator version that only has 10 digits in it. All right, square root of 242. Square root of 242. Well, let's see. Is that something that represents a perfect square? So square root 242. And I get decimals, so it's definitely not a perfect square. So let's see if it's something that we can break up into two different factors. So what times what equals 242, and I need one of those to be a perfect square. Let's see, 242 is the number. Oh, 243, that's close, but that's not quite the same. 245, no, that doesn't work. 252, no. Nothing there, nothing there. I can't see those numbers, they get too big. Oh, you know what? I missed it. I started too late. 242 is right here. It is the result of 121 divided by 2. 121 is 11 times 11. All right, that's my perfect square. So 121 times 2. I always like to put my perfect square first when I do this, because when I split things up, when I use that product property, I know that this is the one that I can simplify. And I said 11 times 11 was 121. So the square root of 121 is 11. And I bring down the square root of 2 in its place. All right, so we're saying that the square root of 242, which was 15.556344919, continue, is going to be the same thing as 11 times the square root of 2. So let's double check that. 11 times the square root of 2, enter. Look at that. It's the exact same thing. So we simplified it correctly. If you get a different number here, that just tells you that this is not the same. You simplified it incorrectly. So be careful with that. All right, this is a good opportunity for you to try, so feel free to pause the video, try these two. Remember that multiplication table is in Schoology in the Unit 7 folder. So pause the video, give it a shot, and when you're ready, click play and see how you did. All right, so let's check and see how we're doing here with the square root of 90. Now, we do know that the square root of 90 is not a perfect square, because I get a decimal when I do that, 9.4868, so on. So I want to try to simplify that radical. So I have to try to think about what two numbers will multiply up to 90, and which one of them is a perfect square. And you might be able to do this even without the chart. I'm going to find my chart. There it is. 90, let's see. I can't divide 90 by 81. 90 divided by 64. Nope. 90 divided by 49. Nope. 90 divided by 36. Nope. 90 divided by 25. Oh, no, not quite. 90 divided by 16. No. How about 90 divided by 9? Well, yeah, 90 divided by 9 is going to work. That's just 9 times 10. Okay, so 90 is the result of 9 times 10. So I put my perfect square first and my other factor second. That allows me to break it apart into two different radicals. And then I also know that I can then simplify the square root of 9 is 3, because 3 times 3 was 9. And then the square root of 10 is just the square root of 10. So notice I'm only simplifying that part that I crossed out, the part that I canceled. The square root of 10 cannot be simplified. It's a decimal value. and I can't simplify that any further using the same process. So we should get 3 times the square root of 10. Let's check and see if that is the same as the square root of 90. So 3 times the square root of 10, enter, and it is the exact same thing as the square root of 90. All right, the last one's the square root of 300. Well, I have my calculator up. Let's double check that. All right, it's a decimal, so it's not a perfect square right now, so let's see if there's a way of breaking it down. Well, I recognize, without going to my chart, I even recognize that I know that this is 100 times 3. And 100 is a perfect square because it's 10 times 10. So I'm going to start by breaking this into 100 times 3, which was 300. And then I can break that up into 2 different square roots using my product property. And then I know that I can simplify the square root of 100 is exactly 10. And then I bring down the square root of 3 to be with it. So it should be the same as 10 times the square root of 3. Let's check. 10 square root 3. It is the exact same decimal value. Awesome.